This is an introduction to organic chemistry. Organic chemistry is the study of compounds which contain the element carbon. The element carbon is also often found with 4 or 5 other elements. C is found with H, O, N, S, and also sometimes phosphorus in organic molecules. Now, these are all nonmetals, and so what they do is they covalently bond with each other and with the carbon. If they are covalently bonded, then we are discussing molecular substances. And that's the critical idea. What we're dealing with here are molecular substances. And some of them are small, like this picture over to the left here, which I'm about to circle so you can see it. That's methane. Methane is the gas that's on your stove. It's the gas that comes out of our Bunsen burners. All right. Organic chemistry, we're going to cover a short introduction to it, basically. If you go to college, you take 1 year of inorganic chemistry and 1 year of organic chemistry, which most students find more difficult. Just to give you a broad purview of what we're talking about here, okay? Just a few things that you've come in contact or heard. This list over to the right, acetone, which is nail polish remover, octane, which is a gasoline, kerosene, propane for your barbecue, oil paint, and paint thinner, your DNA, protein, lipids, most of the pharmaceuticals, whether it's aspirin or ibuprofen, okay, or somebody who's taking steroids, those are all organic. Cortisone's organic. Antibiotics are organic molecules. So we're surrounded by organic molecules, and they are incredibly important to how we live. Now, I'm going to give you a broad generalization on the properties of these organic molecules. All right. And it's really a broad generalization. So the general idea of these is they are molecular substances. If they're small, they tend to have low melting points. And again, as molecules get larger and have a heavier mass, the London dispersion forces get stronger, so they tend to have higher melting points. So a big molecule like a lipid or a protein will have a much higher melting point than a small molecule like methane, which is a gas at room temperature. A lot of these guys you know by their smell. And the reason why you know by their smell is because for the smaller ones, they evaporate so readily because the IMFs are weak. So many of them have, particularly these guys over here, have relatively weak IMFs. You can't smell protein or DNA, but you can definitely smell oil paint or acetone or the octane in gasoline when you're at the pump, right? That's because they're evaporating so readily, which means they tend to have a high vapor pressure. And that's why you can smell them, because the molecules are escaping and they're getting into your nose and you can actually smell them, right? By the way, a lot of them are toxic. They are not good for you. Some of them are, in fact, carcinogens. So, you don't want to, you wear a mask when you're doing oil painting to make sure you have good ventilation because of that, to be safe. All right, so they have low melting points, high vapor pressure. They tend, I'm going to write the word tend in front of this, to be what they call non-electrolytes. That means they don't conduct when they're dissolved in water. And many of them are soluble in water and some are not, okay? So that varies a lot. There are exceptions. I'll put the exceptions over here. The exceptions are the organic acids and bases. So there are organic acids and organic bases. All acids and bases are electrolytes, so they tend to be non-electrolytes. Some are nonpolar, okay? Many are nonpolar, not all of them. And those that are nonpolar might be insoluble in water because they're not like water. So you might have heard oil and water don't mix. That's because oil is a nonpolar organic molecule, right? Oil paint does not mix with water, right? If you want to clean off your oil paint off your brushes, you have to use a solvent that is not water, okay? Whereas some paints you can use water to clean off the brushes. It has to do with what the paint is. Is it a polar or nonpolar solvent that's in the paint? Other properties, if they are solid, okay, you probably see they tend to be soft. So very, very quickly, briefly, they tend to have low melting points and high vapor pressure. If they tend to be non-electrolytes, with the exceptions of acids and bases, many of them are nonpolar, and those that are nonpolar are insoluble in water. So things like oil and acetone do not dissolve well in water. Gas doesn't mix with water. Gasoline is nonpolar, water is polar, and they do not mix well. Okay, down below you see this diagram. What this diagram is showing you is ways of illustrating an individual molecule of an organic substance. And the ones I'm going to focus on are what's called the molecular formula, the structural formula, and the condensed structural formula. I'll talk briefly about the perspective drawing, but I'm not going to emphasize it. Okay, very briefly. What the molecular formula does is just tells you the numbers and types of atoms. So this molecular formula, which is the molecular formula of an alcohol called methanol, a single molecule of methanol has one carbon, four hydrogens, and one oxygen. And you'll notice the order. Carbons first, then hydrogen, then oxygen. This is the order in which we write molecular formulas for molecular substances. So carbon, if there's 5 carbons, it'll be C5. If there's 6 hydrogens, will be next. If there's no oxygen, if there's just nitrogen, it'll be like C5, H this, N this. If there's oxygen, it'll be C5, H this, O this, then N this. If there's S, that comes last. All right, but it doesn't tell you how things are organized within the molecule. The structural formula does tell you how things are connected, but it's 2D. Okay, it's basically a Lewis structure. And remember, in between the O and the H here, there is a dash. They do that for spatial considerations, meaning they don't want it to take up too much space. So sometimes they'll leave out the dash because everybody in chemistry knows there's a single bond between the O and the H, so they don't draw it. All right, now the condensed structural formula basically lists what's attached to each carbon in a molecule. I think I'll do a better job of that on the next page. Okay, so let's say we have this structural formula, and this substance here is called ethane, and later on I'll talk to you about how I know the name of that. Now, what I've drawn here is basically a structural formula. So I've done 2 structural formulas, one for ethane and one for another a molecule called propane. The molecular formula is just the numbers. It goes CHONS, so HONS, just keeping that up there. So I just literally would say the molecular formula would be C2 because there's 2 carbons here, and there's 1, 2, 3, 4, 5, 6 hydrogens, so it would be C2H6. For propane, its molecular formula would be C3, and it has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, so I write H8. That's its molecular formula. The condensed structural formula, which is the one I want to talk about now, basically lists what's attached to each carbon. Now, the first example that was here in the top from the textbook that I found is that it only has 1 carbon, so it really is not a good way of illustrating a condensed structural formula. So if I get to ethane, what I'm going to do is this. I'm going to take each carbon, I'm going to look at the first carbon right here, and I'm going to write down what's attached to that carbon besides the other carbon, right? So what's attached to that carbon besides the other carbon are 3 hydrogens, so I write CH3, and then I write CH3. Now, what's the point of this? Literally, it means that it takes up less space. It's like you're taking, and you're not showing the bonds, but you're showing what's attached to what, okay, by the way you list it. So for propane, the first carbon, I'm going to write 1, 2, 3, right? The first carbon has 3 H's next to it, so CH3. The second carbon only has 2 hydrogens, so we write CH2. And the third carbon has 3 hydrogens, so we write CH3. And everybody understands that the carbons are connected to each other, and the hydrogens are attached to the carbons. So if I show that to an organic chemist, they're like, okay, the 3 carbons are connected to each other, and on the first carbon there's 3 hydrogens, the second there's 2, and the third there's 3. Didn't write the hydrogens, just wrote dashes for time's sake. Now, let's look at one more of these. So let's say you have this. Now this is called propanol. Propanol is an alcohol. Propanol is an alcohol. It has what's called a hydroxyl on the end. This is a hydroxyl. We've seen these before. When did we see them? When we talked about acids and base, because a base like sodium hydroxide had what's called a hydroxide. And these look so alike that they would mess you up in questions. Propanol is not an electrolyte. Unlike this, which is a base, which is an electrolyte. We're not going to talk about this anymore. This is a hydroxyl. Now, we're going to write out the molecular formula first, and then we're going to write the condensed structural formula. Okay? So here we go. So we just literally count up the C's first. We count 3 C's, so we go C3, and then we count the H's. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 H's. And then we do the O, because that comes next in Chons, right? And that's our molecular formula, all right? So the molecular formula really doesn't tell us how anything is organized here at all. So that's why we have condensed structural formula. So I'm going to label this 1, 2, and 3. So I'm going to write C, and I'm going to write, it's got 3 H's, so I'll go CH3. The next carbon has 2 H's, so I write CH2. The third carbon has two H's and a hydroxyl. So I want that hydroxyl to be seen because that's what makes this an alcohol. All alcohols have hydroxyls. This is propanol, not drinking alcohol. There's other alcohols like ethanol. That's what's in like beer and wine and stuff, right? Okay. So I drew it this way. I draw out these two H's like CH2, and then I separate and put the OH there. So this way I see the special thing. Okay, this is called a functional group that makes this an alcohol. We'll get more into this later. Okay, so what do you need to know? Organic molecules tend to be soft, have low vapor pressure. They tend to have the element carbon in them. The other elements tend to be H, O, N, and S. You should be able to do a molecular formula, and you should be starting to get comfortable with condensed structural formulas.